Hi everyone, this section is about arithmetic and geometric series. So in the previous section we learned about arithmetic and geometric sequences, so we're just continuing our knowledge here. In this video specifically I'm going to be talking about using arithmetic series, and an arithmetic series is the expression formed by adding the terms of an arithmetic sequence. So basically we're taking like a series and we're figuring out what the sum, if we were to add all of them together, would be. So we use this kind of formula here. The sum of the numbers in our series is equal to n times the first term plus the last term divided by 2. So we will be referencing this quite a bit in this section here. So for the first part here, it says find the sum of each arithmetic series. So there's a couple of ways that you can do that, and I'm trying to simplify this as best as I can for you. So basically, we have our first term here, second term, third term, fourth term, and then we've got just some dot dots happening here, basically skipping ahead to the last term, which is 32, but it's leaving out some pieces. And it's wondering, well, if we had all of these numbers, what would they be added up together? So like I said, I'm trying to simplify this. There's definitely a couple of ways that you can do this, and probably some more like mathematical ways, I guess, that you could do this. But for now, what works is just trying to figure out, well, what are we missing here, okay? Because to use our formula, to use that formula, we need to have an n, which is how many terms are there, right? Then we need our first term and we need our last term. Well, we know our first term, that's 5. And we know our last term, that's 32. But, you know, like 5 is our first term, 8 is our second term, 11 is our third term. 14 is our fourth term. So what term is that? So how many terms are there, right? So we're going to figure that out. So let's rewrite this and fill in the dot, dot, dots. So I've got 5, 8, 11, 14. And you guys can probably see here that we're adding by 3 each time. So to fill in, I can just keep adding by 3. So that would be 17, 20, 23, 26, 29, and 32. So what we can see here is we've got our first term, second, third, fourth, fifth, sixth, seventh, eighth, ninth, and our 10th. So we've got 10 terms here. So that means n is equal to 10. Okay, so now we've got n to plug in here. We've got our 5 to plug there, and we've got 32 for right there. So we have everything that we need to finish this. So the sum of our 10 terms is equal to 10 times 5 plus 32 divided by 2. And I mean, you can always kind of like simplify a little bit. Like, let's say I did 5 plus 32, okay, divided by 2 times 10. All right, so that would be equal to 185. Okay, so let's do another one. Very similar. If you wanted to pause it and try it on your own, go for it. So same idea. What's the sum of all of these terms? So we're going to use our formula. Okay, and we need an n. We need our first term, and we need our last term. Well, I can see our first term is -2. It's easy. Our last term is -30. But how many terms are there? Like -2 is our first term, second term, third term, fourth. But what one is that one? So we're going to figure that out. So let's rewrite them out. I've got -2, -6, -10, -14. And let's fill in those dot, dot, dots, right? So it looks like we are subtracting 4 each time, right? So to fill in what we're missing, well, that would be -18, -22, -26, minus 30. So I can see we've got 1, 2, 3, 4, 5, 6, 7, 8 terms. So we've got our 8th term here. So n is equal to 8. So now we can go ahead and plug everything in. So the sum of our 8 terms is equal to 8 times negative 2 minus 30 divided by 2. All right. So, again, it's pretty easy to like negative 2 divided by, or I'm sorry, negative 2 minus 30 divided by 2 times 8 would give me negative 128. So the sum of all those numbers, 28. Okay, so hopefully that makes sense on how we find the sum of each arithmetic series. Now I need to go to the next section where we talk about summation notation and sigma notation. So you're going to start seeing this. It kind of looks like an E a little bit. That's our Greek letter sigma. That's our summation symbol, and that means to sum things up. This top part here is like the end, how many terms we have. Our index variable, it's like where we start with the terms, and then we have our formula. So again, I'm going to make this as easy as I possibly can. So stick with me here. Let's just start with an example. So it says find each sum below. So like we're still going to be finding our sum. So we need to use our formula. So that's still a thing. That's still happening. Sorry, let me... Okay, so we still need like an n and a first term and a last term, right? So, actually, you know what? Let me write these over here because I can use them over here. So n equals first term equals and our last term equals, okay? So your last term, that's our n, and you can see that if you were to go back up here where it says n. So that's where n is located. So we've got that. So I'm going to write down 15 for n. Now we need our first term and a last term. So basically what you do is you take this formula, okay, and you plug in what you want, okay? So like we want the first term. So I'm going to plug in a 1 because I want the first term, okay? So 9 plus 3 times 1 would give me 12. Now, something I didn't say before, which I'm going to kind of change my mind here, because we already know n is 15, that means there's 15 terms. So we want to know the first term, but the 15th term is our last one. So we're going to take 9 plus 3 times 15. 9 times 3 plus 15, that would give us 54. Okay, so now we have everything that we need. We've got our first term and our last term, and how many terms there are. So let me just rewrite this a little farther over. Okay, so the sum of our 15 terms is equal to 15 times the first term plus the last term divided by 2. All right, so same kind of idea here. We could take 12 plus 54 divided by 2. So that's what's inside the parentheses, and then times 15, which is 495. So our sum of our 15 terms is 495. Okay, so let's do one more example just so you can kind of get the hang of this here. And, you know, if you want to pause it and try it on your own, I'm all for it. It's all good things. Okay, so we're going to find the sum. So our sum formula, let me rewrite that again. And remember, we need an n, a first term, and our last term, which we know already is going to be 6 because n is 6. Okay, that's a terrible arrow. Try again. Okay, that's a little better. Not great. So we're going to take 3 times 1, and we're using the 1 because we want the first term. And then 3 times 6 because we want to know the 6th term. So that would be 18. So now we can plug everything in. So the sum of our 6 terms And if you forget to do like the S6 or like the S15 up here, I mean, it's not like the end of the world. It's just like how we would write it. And then we've got 6 and 3 plus 18 divided by 2. So the sum of our 6 terms are, so we've got 3 plus 18 divided by 2, and then that was times 6. So we've got an answer of 63. Nice. Okay, so that's it for arithmetic series. In the next video, I will talk about geometric. All right, thank you.